Okay, so I just want to start this video saying all the information that I'm sharing with you can be found in my book called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. It's available through Amazon. So I've been sharing with you this geometric pattern that is built on the base 12 Cartesian plane. We are going to the fourth ring of the pattern. I've gone over its dimensions in previous videos. You can see I've drawn 8 circles. Each of these circles has a diameter of 0.96 root 2. So the total length of that line, or the distance across the diameter of this dodecagon, is 0.96 root 2 times 8, which is 6.4 root 2. So these are base 12 or Dozenal numbers. Okay, so what we're going to do now, dividing the diameter into the perimeter. So we're going to place these circles onto the corners of the dodecagon where we have this line that is perpendicular to the 45-degree line. And there's lots of little lattice points all along there. And we're going to be placing our compass, this is my compass, on one of those lattice points and drawing these circles. So basically placing them on either side of that 45-degree line. Okay, so you can see I placed those 2 circles on either side of that 45-degree line, anchored on that section of dodecagon. So this is what that looks like. These are those circles. They have a radius of 0.49 root 2, a diameter of 0.96 root 2. This distance from the center to that midpoint is 0.5 root 2. So 0.5 root 2 minus 0.49 is 0.03 root 2. So that is the gap between the circumference of the small circle and the very end of that line, and also the circumference of that circle and the midpoint of that line. We have the same thing on this side. So the total dodecagon section, that length of line here, this length of line is 1.8 root 2. So 2 times 0.96 is 1.7. So these 2 circles added together is 1.7. Subtract one from the other, you get a distance of 0.1 root 2. So 4 times 0.03 root 2 is 0.1 root 2. So we got 4 little sections of 0.03 root 2. And in the center here, there's a gap of 0.06 root 2. 2 times 0.03 is 0.06. Then you can see I put a circle around the whole thing, also centered on that midpoint. So that diameter of that circle is also 1.8 root 2. So in the next video, we're going to look and see how we can do that same thing with the other sections of dodecagon. How do we arrange them so everything is equal and balanced in the diagram?